We're now going to move on to velocity time graphs. They're not that complicated at all. You've just got to be really careful on the day of the exam about these two things. Is it distance they're putting up the side, or is it velocity they're putting up the side? So be careful, please, I must say. Now, we've talked about this one, so let's have a quick recap. Here is a snowboarding cat. What is it doing? Let's follow with me. It's travelling at a constant speed, great, stationary, constant speed, constant speed. Where is its highest constant speed? There, because it's steeper. Fabulous. Here is its lowest constant speed because it's less steep. Okay, so that's it. Marvellous. Now, velocity time graphs. Velocity, just to be clear the differences between velocity and speed. Velocity is in a given direction, so you can have negative velocity, but you can't have negative speed. So say you were running along, you were going at 4 meters per second, that's your speed, and that could be your velocity. If you were running backwards, you could be running backwards at a speed of 4 meters per second, but you'd be going backwards at a velocity of minus 4 meters per second. So treat it as the same, but velocity is in a given direction. The graph looks the same, but in actual fact, what's happening to the snowboarding cat is different. So on this bit here is stationary, but on this bit here is doing something very different. So let's have a look at those things, and then we can come back to it, which would be good. So here we have a journey of a cat with its tail on fire. Now don't worry about these bits here at the moment, we're just looking at this. We're going for the foundation tier. We're ensuring at the moment that we can say what the graph shows. Don't be put off by this beautiful cat. His tail's not really on fire, it's okay. It's a cartoon. Right, now, along the bottom then, I've got the time, and at the side, I've got the velocity in meters per second. As I say here, think about it. This is a speed. It's going at 1 meters per second, 2 meters per second, 3 meters per second. Okay, so really do be careful. So if I look and try and interpret what's going on, I can say at this first stage, after 30 seconds, it's going at 4 meters per second. At 20 seconds, it was going less than that. At 10 seconds, it was going even less. So this thing here, this cat, is speeding up. Now you can say speeding up, or you can use the proper word, speeding up, which is accelerating. Accelerating, so it's accelerating. It's accelerating from 0 to 4 meters per second in 30 seconds. So if you want a total description of the graph, don't forget to use those units. So after 30 seconds, it's gone at it's reached a speed of 4 meters per second. Now on the other graph, the distance time graph, this would be in a constant speed, but in this one, it certainly isn't. Now what's happening here? Well, here at 30 seconds, it's going 4 meters per second. At 40 seconds, it's going 4 meters per second. At 50 seconds, it's going 4 meters per second. So it's going at a constant speed of 4 meters per second. Constant speed. Do you remember what it is on a distance time graph? Well, on a distance time graph, this thing would be stationary. But on this one, a velocity time graph, speed time graph, here, this is a constant speed. Here, again, we're accelerating. We're zooming up to 5 meters per second. And here, we're going at a constant speed. So that is what's going on with the cat. Quick recap to this. Speeding up, we're accelerating. Constant speed, speeding up, accelerating, and accelerating even faster because it's steeper. Now if the line came down, it would be slowing down or decelerating. And we'll have a look at a few more things about what we can do with velocity time graphs in the next exciting video.